All right. So I'm doing domain and range, and we just went over the definitions. So I want to verbally talk about what those definitions are. We're on 3.1. Domain is all my x values. So if I were to look at a graph, it'd be going from left to right. My range is all the y values. So range is my y values. All right. A function. So I wrote some things in green on a function over there. It says for every input, there must be one output. So for a function, which is a relationship between numbers, and you've already written this. Yeah. A function has all different x values. So no repeating x's. That's like a big rule in function. No repeating x's. So here's a task I want to do to kind of help you understand what functions are. I need some volunteers, and my x is my input, which is also my domain, right? I'm making a table of values. You don't have to write down this table of values. I'd prefer you just watch. So I want to know, I need some volunteers. And since we're recording, I want you to lie to me. Okay. Yeah. No, you've already helped me today. So I need people's names and the street that they live on. So obviously don't tell me the truth because this is on YouTube. This is on YouTube, guys. So yeah. Yeah, that'll be fine for me. Yes, go ahead. Name. Oh my gosh. Where does he live? The Gates? Just call it Gates because, or the Gate Street, whatever. That's too long. That's too long for a street sign. All right. So one man, his house is on Gate Street. Okay. Great. I need another person. No, you've already helped. You've already helped me. Yes. Elmo. Elmo lives. Oh. Great job. Does Elmo have any other people that live on Sesame Street with him? Oscar. Okay. So this would be like his sibling, right? Put your phone away. Or actually, I'll just take it on my desk. Bring it up. So I need another name unrelated to these people. Yes, Alan. Edgar. Don't tell me his real street. Go. He lives next to school. All right, so Edgar, do you have a brother or sister?
Yeah.
What's their name?
Yesli.
Huh?
Yesli.
Yesli?
Yeah, Y-E-S.
Oh, I see. Okay. Okay. Thank you. So these two people live in the same house. Elmo and Big Bird live on the same street. They go to the same place at the end of the day. So my point is, for every input, every person has a place to go. What if Yesli decided, gosh, I want to go to Dorothy Lane, but at the same time, I really want to be at Sesame Street too. Could Yesli be in two places at once? No. So Yesli, if Yesli was trying, I don't need conversation right now because I need to get through this. If Yesli is trying to be in two places at once, that means that she would be repeating. Her name would be written twice. And she can't be in two places at once. This is not a function. Yesli's situation here is not a function. Yesli cannot be in two places at once. So I can't have any repeating x's. All right, every input must have its own output. A function has all different y values. Obviously, you notice that I don't care if I have repeating streets. Lots of people could live on the same street. But I cannot have one person trying to split themselves in half and be in two places at once. That's not going to work. So the same thing would happen if I gave you a table of values and I said, oh, -1, 0, 1, 1. And they all can go to different places. But here's my problem. I cannot have this situation right here. The 1 repeats. This is bad. I'm going to say no. This is not a function. No repeating x's at all. So I want to now transition and go to your 4 problems that we have here. So here's what I want to do for each question. I first want to talk about if I can write down the domain and range, and I'll write this one. So I said earlier that the domain was all of the x values. Can somebody tell me what the ordered pairs are? These 3 dots. What are the ordered pair names? 2, 2 is one of them. You're right. What else? 0, 1 is another one. Correct. Give me the last order pair. -1, 2. All I want you to do is look at the x values. I got a 2, a 0, and a -1. Are they all different?
Yes.
Yes. So I'm going to say yes. This is a function. My domain is all my x values. That would be the things I underlined. 2, 0, and -1. So I'm going to make a list of my domain. It's 2, 0, and -1. And then I'm going to tell the ranges. I'll underline those in a different color. That's my y values. 2, 1, and -2. Oh, not negative. Whoa, just positive. And the last question I have for you is this discrete or continuous? This graph, is it discrete or continuous based on my definitions? Discrete. Discrete because it's just dots. Dot, dot, dot. Discrete. All right, let's do the second one. I'm going to list the order pairs in a T-chart, table of values. Input, output table, T-chart, table of values. All synonyms. All right, let's start here. What order pair is my pencil on? Negative what? Negative what? Not Montana. Someone else new that has not volunteered. Yeah. -2. Yeah, -2. Good. I don't see it in here. Bring it up. What's this dot here? I'm going in order from least to greatest. -1, comma. -1, comma 2. Yep. The next order pair would be this one. What is it?
1, -1.
1, comma -1. And someone else, tell me this one. No, stop. He can do it.
-2, -2.
Can he do it himself, please? And he's wrong, actually.
Oh, damn it, kid.
Yes, Sachika. 2, 3. Please look at all your x values. Is this a function? Yes or no?
Yes.
Remember, I want them to be different. I want them to be different. Yes, a function. And my domain, -2, -1, 1, 2. So I just made a list. My range is all my y values. -2, 2, -1, 3. Is this discrete or continuous?
Discrete.
All right. Can you tell me if this is a function or not? This third one, this line. I'm going to zoom in because I need to be able to write ordered pairs on it. Okay. How would I know? Every other thing I've been given, these two problems above it, I was given ordered pairs. I'm just given a line this time. How am I supposed to figure out whether this is a function or not?
Because you look at the x.
I look at the x values. What are my x's? I guess I better do a color. -1, 2. -1, 1. -1, 0. Huh. Let's make an educated hypothesis right now. What do you think? Is this a function, yes or no? No. Why is it no? Tell me why no. Repeating x values. You're going to be asked why or why not. I cannot have x's repeat, and these do. That's bad. Nope. So what else do I need to figure out? Oh, is this discrete or continuous? I'm not going to do domain and range yet on a straight line because we do that later. Last question. How would I be able to tell if this was discrete or continuous? No, discrete or continuous. Okay, you've already volunteered. New people, please. You've already volunteered. I shouldn't have to tell you that you've already volunteered. Don't you know that you've already volunteered? Come on. Yeah. It's a line. Oh, continuous then. Yes. Continuous. Could you spell that in a spelling bee? No. Continuous. If I had the word right in front of me. X value. That's what I'm looking at. That means I'm going to do this ruler here. Are my X values ever the same? No. They all kind of just, that's a different X value than that, than that, than that, than that. So it's yes, a function. It's always going to be a function unless there's dots that overlap or there's a straight up and down line. Good. So I want to do example 1 with you just to kind of get you started. Your job is this whole page, front and back. So here we go. I have to represent this. The rest of the questions are easy. I have to do if it's a function, yes or no. So that's straightforward. And then I have to do, on the second page, it says, is it continuous or discrete? So number 1 is different than all of them, and so that's why I want to go through it. I have to express this in different ways, 3 different ways. Here's my order pairs. I need to give a table of values. So my x is xy, xy. Is going to be -5, 3, -2, 1, 1, -1, 4, negative 3. And then, if I have a mapping diagram, that's what this is called, I draw arrows connecting my x to the appropriate y. Like negative 5 goes to a positive 3. Negative 2 maps to positive 1. 1 maps to negative 1, and 4 maps to negative 3. And then you can plot the ordered pairs on the table of value, or on the coordinate plane. So you've got front and back. Is it a function? Yes or no? And explain why or why not.